In this video, we'll generate the trend line and trend line equation of sine and cosine using Taylor-Maclaurin series sum, array formula, data validation, and LINEST polynomial regression. We start with the array formula on cosine. So array formula, cosine of the x values from 0 to 6. And here you have the trend line and the trend line equation of cosine, polynomial to the 6th degree. Next, we generate the sine. Array formula, sine of the x values from 0 to 6. And here you have the sine function, where you have the trendline equation of sine polynomial to the degree 6. And we generate the Taylor-Maclaurin series sum of both, uh, where it is the summation of a times x to the power 2n plus m, where the value of n is from 0 to infinity. So we have n 0 to infinity. In this case, we'll get to 12, which is good enough. And the value of m is 0 or 1. So data validation, that's list of items, 0 if it is cosine, 1 if it is sine. So 0 if it is cosine, 1 if it is sine. And we generate the Taylor-Maclaurin series sum expansion, series sum of the x values raised to the power starting from m, which can be 0 or 1, incremented by 2. That's 2n. So 2 by 2n. So 2, 4, 6, 8. So the interval is 2. And the coefficients will be this range. Now we'll complete the coefficients, which is equal to array formula minus 1 to the power n all over factorial 2 times n plus 1 plus m plus m. In this case, it's 0 if it is cosine, 1 if it is sine. So we can select. If it is 0, the expansion in red is cosine. If it is 1, the Taylor-Maclaurin series sum is sine. You'll notice the green data sets. That means it's sine. Well, the blue data sets are cosine. So if it's 0, it is cosine. Next, we calculate the coefficients, these regression coefficients the using LINEST. To do that, we'll complete the 1 comma x matrix, starting with the power, which is equal to transpose from 0 to 6. And the 1 comma x matrix will be array formula of the x values raised to the power 0 to 6. Now we can enter LINEST. So LINEST of data y, that's for the cosine, and data x. And the Taylor-Maclaurin series expansion, which is our LINEST, data y, and data x. And this sine function, which is LINEST, data y, and data x. So we can compare. If m is 0 for cosine, these values are the same. So that means the red line is on the blue, covers the blue datasets, and their regression coefficients are the same. They are the same. m equals 1, which is sine. The red line covers the green, and the regression coefficients are the same. So these regression coefficients of the expansion and sine, they're the same. 0.904x, 0.225x squared, minus 0.358 x cubed, they're the exact. So again, going back to 0 for cosine, the regression coefficients are the same. For sine, m equals 1, the regression coefficients of the sine and the expansion are the same. This completes the use of Taylor-Maclaurin series sum, array formula, data validation, LINEST polynomial regression to generate trend line and trend line equation of both cosine and sine.